Good morning, everyone. My name is Jiro Arroyo from Group 6 with Enrich Miras, Joshua Villanueva, BSCPA 2B. Storage Management. What is storage management? The methods and technologies used to manage the resources, program, and hardware that go into a data storage system are collectively referred to as storage management. In addition to assuring that availability, resilience, and security of the data that underpins an increasingly digital world. It requires finding the best possible balance between prices, performance, and capacity in this post. We'll go through the key procedures and tools required to provide your organization with big, quick, and dependable data. Common storage management processes. While the exact tools and techniques used to manage data storage will differ between organizations, here a list of common storage management processes. Provisioning, the process of giving computers, servers, and other machines storage capacity. Virtualization, the process of separating software from hardware operating environments by using virtual machines. Containerization, a form of virtualization where application and operating system are separated using fully packaged and portable computing environments. Data compression, a method used to optimize your storage capacity by clearing up disk space, filling up memory gaps, speeding up retrievals, and other factors. Data migration, the process of moving data from one storage location to another. Data replication, for redundancy, resilience, and dependability. Data replication includes storing the same data in various storage places, whether through snapshots or mirroring. Disaster recovery, tools planning, policies, and procedures for restoring IT operation to normal in the wake of a disaster. Automation. Automation includes all technologies and methods related to automating data storage management procedures from straightforward scripts to DevOps. Storage management benefits. It is important to recognize the advantages of effective storage management in a world that is becoming more and more digital. Storage management done correctly should keep the data that powers your company quick, dependable, and accessible every day of the week. Automate, analyze, and streamline the management dashboard to simplify the work of IT employees. By optimizing the capacity and performance of current storage capacity so that you don't need to buy more. You can lower capital expenditures, CapEx, by only paying for the storage space that your company really uses. You may save operating expenditures. Simplified data storage management with Pure1. With the help of Pure1 R, a data storage management system, on-premises storage can now benefit from simplicity of cloud storage and provide a modern data experience. TM, what you receive with Pure1 is a single pane of glass to view and manage all of your storage arrays. Full stack analytics and AI-driven management with the Pure1 Meta-R analytics platform. An anticipatory intelligence that foresees capacity and performance requirements. A customer-centric support system of humans and AI that continuously monitor and proactively resolves issues in your array before they become problem.
Types of storage management. Programmer control storage. When a management is explicitly done by a user or programmer with the help of certain inbuilt functions like malloc or free, that allocates and frees the memory as per requirements. The second one is system controlled storage management. In many programming languages, the storage management is implicitly done by the system only with the help of various language features. Here the difference between programmer and system controlled memory management. Programmer controlled storage management. In this, programmer explicitly control over the storage with some inbuilt function. There is extra burden on the programmer. It is dangerous to programmer as it may lead to the errors. Sometimes programmer may conflict with the controlled system memory management. It is easily and efficiently done by programmer as knows the actual requirement of the application. However, system controlled storage management in this only system implicitly controlled over the storage using some language features. There is no extra burden on the programmer. No such kind of error take place. No such kind of interference or programmer is allowed. It is quite difficult for the system to determine when to allocate and when to read. Major elements that require storage: code segment, system runtime program, storage management routine, user-defined data structure, subprogram returns points, referencing environment, temporaries in expression evaluation, temporaries in a parameter transmission, input-output buffers, and miscellaneous system data. Next, here is the objectives of storage management: to provide the memory space to enable the several processes, to provide the efficient use of memory, to protect each program resource, to share the memory space if required, to make addressing transparent for programmer as much as possible. Next is feature of storage management. There is some feature of storage management which is provided for storage capacity. These are given below. Number one is storage management is a process that is used to optimize the use of storage devices. The second is storage management must be allocated and managed as a resource in order to truly benefit our corporation. Three is storage management is generally a basic system component of information system. It is used to improve the performance of their data storage resources. Advantage of storage management. There are some advantages of storage management which are given below. First is it is very simple to manage for storage capacity. It is generally taken a less time. It is improved the performance of the system. Excuse. Virtualization and automation technology can help an organization improve its agility. Three phases of storage management. First is initial allocation. In the starting of the execution, each piece of storage may be either allocated for some use or free. If it is free, then it is available to implement and use it. Any storage management must have some techniques for keep tracking of free storage as well as allocation of free storage as per need during the execution. Recovery: storage that has been allocated and used, and when it will become available it must be recovered by the storage management for use. It may perform very simple by means of repositioning stack pointer or complex by means of garbage collection. The last one is compaction and reuse. Storage re- excuse Storage recovered may be immediately ready for reuse or compaction may be required to construct very large blocks of the free storage from small pieces. Storage management techniques. First one is static storage management. This simplest form of allocation, which is done during translation and remains fixed throughout the execution. Following are some important points related with the static storage management. Here are the advantage. It is efficient as there is no time or space expanded for storage management during the execution, and the translator can direct generate and value address for data items. Disadvantage: it is incompatible with recursive subprograms call and data structure whose size is dependent on input data. The second technique is stack-based storage management. Stack-based storage management is based on stack data structure that is LIFO. It is needed when language permits direct decursion. The following are some important points. First, allocated last spread. Simple storage recovery, compaction, and reuse. In stack-based allocation, objects are allocating in last in, first out. It could be useful in language without recursion, as it could save space. Each subroutine invocation creates frame or activation record which consists of arguments, return address, local variables, temporaries, bookkeeping information. The last technique is heap storage management. It is based on the heap data structure. Heap is a block of storage within which data are allocated in an arbitrary manner. In this, the problem of allocation, recovery, compaction, and reuse may be complicated. Heap storage management can be one of two types. Big size elements. This is quite simple. Compaction is not problem as all the elements are same size. The second is variable size elements. This storage technique is programmer controlled allocation more difficult than fixed size elements. The major difficulties with variable size elements are use of recovery space.
Storage management issues. Storage is becoming immense and strategically important. Management tools are required to intelligently manage this important asset and to better utilize its staff talents. Included in storage management are data management, storage resource management, storage network management, device management, virtualization management, and management of functions such as backup capacity and performance. The problem of storage management are many different storage management solutions. Essentially, they do not work together. Overlap of functionality. Storage networking has greater demands. New management products for storage networking. Different terminology used by vendors. Network-centric versus storage-centric. Attempts at differentiation. Resulting confusion. And overall total possible gains from storage networking not realized. What is important in storage management? The important in storage management are economics, efficiencies in managing storage, amount of storage administered, accommodating growth, business dynamics, capabilities, problem determination, optimal operation, provable security, and business operations. How to depict storage management. Need to illustrate by what management is being done to understand overall picture. Solutions may cover more than one market segment. Evaluator group broke down the areas or segments to aid in understanding. Terminology may be different from different vendors. And the last one, management is from a storage professional's perspective. Integration of management software. Integration of management software are necessary to provide complete management coverage, avoid duplication of capabilities, single management philosophy, avoid conflicts, simplify training, reduce opportunity for human error, minimize administration of tools, updates or advances, allows new tools to be seamlessly added, and overall greatest economic gain. And the last, Integration possibilities. Integration possibilities are single vendor, lock-in prices, may limit new exploitation of new advances, consortium with shared APIs or new standard, software can cooperate, some vendor software can work with certain others, another matrix of interoperability, and repository base.